So like Ken mentioned here today, my portion of today's presentation will be to talk about the ScanStation P20 very briefly. There are many laser scanners out there in the market. The purpose of today's meeting is to talk to you about the available options that are out there for data collection and post-processing within the 3D world. So I'm going to go into our proprietary Leica software called Cyclone to show today's data. But real brief, this is the ScanStation P20 right here. It's a very simple, straightforward laser scanner, and a lot of the scanners out in the market today are all looking very similar. Onboard controls, internal batteries, so all you really need to be out in the field is a box that contains the scanner and a tripod, and you're good to go. And you simply control the scanner on the onboard controls here. This particular scanner can peak out at over 1 million points per second. The average data collection for customers is typically around 500,000 points per second. So what that translates into for the user is very short station acquisition times. You're probably on station with this particular unit anywhere from 1 minute to 8 minutes, and you're off to your next station. You can stitch your stations together either with a target-based registration or through what we call a cloud-to-cloud. And if you look around the auditorium today, you don't see any targets taped up to the walls or any target poles anywhere. So obviously today we're going to be using the cloud-to-cloud feature that we have. And every major software for post-processing 3D point clouds will have its own version of some type of cloud-to-cloud registration. And registration, by the way, for those who aren't familiar, when you hear me talk about that, I'm referring to stitching multiple stations together. And I would love to go into more detail about the accuracies of our cloud-to-cloud and target-based registration and a lot of our other software features, but we're going to save that for the event later in December. So for now, I'll just do a real quick scan to show you guys how easy it is to operate the scanner. Obviously, you can't really see the screen here, but we go into our scanning tab. We're on the same project that I created earlier. Hit continue. And then from here, I only have 4 options on the tabs at the top. I'll set a field of view, which I'm going to leave at target all. I can change my resolution to dictate how much information on this wall or in the entire point cloud that I want. And it'll tell me a certain distance what my point spacing will be. And right now I have it set on just under a 1/4 inch point spacing at 30 feet away from the scanner. So everything closer to the scanner is going to be tighter, and everything further away from that is going to be farther apart because it's all radial in conjunction with this fiducial point right here on the laser scanner itself. With this scanner, we also have the ability to adjust the quality settings of the data that we actually collect. So as you increase your quality settings, you're essentially telling the scan head to be more picky, if you will, with the data that it retains. So it's going to cut out more noise, and it's going to require more information on each individual point it collects to actually store that point as your data point. And as you lower your quality settings, you're going to tell the scanner, okay, accept larger points for data, more noisy points for data as well, and you're going to be able to scan on position faster also. So I'll just drop this down, drop the resolution down a little bit here, and then I can simply hit scan plus image or just scan from here. The other 2 tabs that I didn't show were the filters tab, so you can tell the scanner at a certain distance start collecting data, and at another distance stop collecting data. So you can essentially dictate the amount of data that you collect out in the field. The only real purpose for that is to control your data file size when you're out in the field. This scanner peaking at over 1 million points per second can obviously collect a lot of data in a very short time frame. And if you've got 12 to 25 stations per day out in the field, you're going to want to make sure that you're only collecting what you really need to keep your file size manageable. Then the other feature, the other tab, was the imagery as well. So you can actually scan and turn on the video camera on the onboard controls to adjust your brightness of your camera, or you can leave it on automatic, which I have done, and it will automatically adjust every time it takes a photo. So as you can see, the scanner just spins. It collects data in both directions at the same time, so it only needs to rotate 180 degrees to get a full dome scan. And then from that, it has a thumb drive where we can download the data and take it anywhere with us. You can see an antenna on the top of the scanner is there too, so it's wireless. And you can also use a wireless data copy tool that we have that will import the data wirelessly. And actually now, because Wi-Fi speeds have been so well improved over the years, that speed is actually faster than grabbing it off of a USB 3 memory stick. And for those of you out there that may be familiar with the old school scanners, we do have a cable, LEMO to Ethernet, that allows you to plug into the base of the scanner and hook it up to your laptop and run the scanner with your laptop as well. So very flexible, a lot of different options. So once we download the data, which I've already done, I set the scanner up against the wall over there, roughly in the middle of the auditorium. And that is going to be station number 1 right here. So the coloration that you're looking at is based off of intensity mapping, or the intensity of the objects that we collected. So the reflectivity. So your best reflective or most highly reflective objects will come back to you at blue, and your least reflective objects will come back to you at red. If you all look behind you, that wall up there at the back is completely black, and that's why we're seeing a red on the wall here. Now, I can rotate in any direction, and this is in true 3D space now. And the data you're looking at here, by the way, was collected in under 3 minutes. But this is a true 3D model space view, so I can come all the way out in any position to view this data. So as you can see from the large circle of missing information right here, this represents where the scanner was located. And then station number 2 is where the scanner is currently sitting. And we had, a couple of us just roaming around here while I was scanning earlier. I think Ken is so sexy in 3D. But we can make him even more attractive by throwing true colors on him as well. So now I've taken the colors from the imagery and applied them to the point cloud itself. You can see our lunch sitting there waiting for us and everything. So all I'm going to show today is the quick registration process that we have. And to do that, I'm going to go and create a whole new registration. Once I open this registration, I need to add scan worlds to my current registration. So I'm telling the software which 2 scanner positions that I want to put together. So we have these thumbnail features here now in Cyclone that also give you the same ability to view the point cloud and figure out where you were in space. So imagine if you have a project where you have to go out and you're expected to get 20 to 25 stations per day. Instead of just these 2 thumbnails here, you would have your 30 or 25 or 30 stations here. You can increase or decrease the size of the thumbnails, and you can visually go into each one, open up a true space, and then visually check where you were in that particular space. You can navigate through the different thumbnails here and then open what's called a visual alignment. So you can leapfrog from station 1 to station 20, or just go in order from 1 to 2, however you would like to do that. Now that I'm in my visual registration, and this is a brand new feature with our software, I simply have point cloud number station 1 in orange and station number 2 in blue. And I can navigate with my plan view and put one station over the other. And what I'm looking for here is a pivot point that I know is identical to each station. And then I place a pivot point in line, and then I grab this pivot tool, and then I can rotate the point cloud to where I think I have them lined up. Once you get them close, you can zoom into it, and I like to get at least 2 corners and then make my fine adjustments from there. And since I'm contending with a little bit of the curtain on this one, I'm going to leapfrog back to the back side, the back wall over there here in a second. But if you see it, notice here, I'm focusing on this corner here, because I want to, as long as I make sure I have one corner lined up really well, you can see on the far corner over here that I'm off a little bit. That's not a problem. What I want to do is zoom in a little bit closer, grab my pivot tool, and then pivot again from here, and I can line those up and make my fine adjustments. Come back to the back corner here, zoom in even closer, and make any fine adjustments if I need. And that looks pretty good. So now I'm done with my horizontal alignment. So now I need to switch over to a side view and actually adjust my vertical accuracies. So you want to zoom in a little bit and then bring station 2 down into station 1. That looks pretty good. Now I'm going to hit the Optimize Constraint button and see a graph that opens up that shows the results that I'm getting. And with this, I have an average error of just over 1/10 of 1 inch from that visual alignment tool. And it's asking me if I want to use this as a cloud constraint to merge groups. I'm going to say yes, but I don't even have any groups. What it's referring to is here in my thumbnail tab, if I had 25 stations, let's say, and I'm telling the scanner to automatically align my scans together, if for some reason between stations 1 through 12 and 13 through 25, if I don't have enough overlay between those two, it will automatically create a group 1 that has 1 through 12 and a group 2 that has 13 through 25. So what that box was asking me is if I've grabbed one station from the first group and another station from the second group, do I want to use this new constraint to tie those two groups together? So it's a fantastic way to navigate through 25 scans and constrain them together. So now here inside my registration, I want to go to my constraints list just to visually check and view my errors again. Then go back to my Scan World tab. I want to look at group 1 now that it just created and view the interim results. So it's going to take me to station number 1 automatically, but I can see that I have station number 2 right down here. But now station number 2 also has point cloud information on the ground from station number 1. So the only purpose of your view of the interim results is to QA/QC your work. So I'm going to grab a point on the wall close to the ceiling over here, and then I'm going to open up a new tool that we have called Quick Slice. Turn off my reference plane, and I can zoom into the registered point cloud of the auditorium and just visually QA/QC the lines, make sure the walls look like they line up, which they do. I can go into my Scan World Explorer and actually discolor each station a different color. So now if I go in here to the corner, I can see that I have a light turquoise with a blue. These represent the two different stations that I have, and you want to make sure that they line up and create one wall. So I can zoom in as close as possible, and I can see that they do in fact overlap on that one wall, that one surface. So it'll be very easy to create a surface off of that. Then I can also toggle up and down throughout my quick slice. Again, this is more of just a visual QA/QC tool for you, and you can see the chairs from the auditorium start to come in as I'm leaving the ceiling area and coming down to the floor. So at any point, you want to check close to the top, you want to check close to the bottom, and just come in here again and look at your wall on the side again. And again, we can see that we've got one nice wall. So everything looks good. Excuse me. From here, we simply tell Cyclone Register that we do, in fact, want to register these two stations together. Then we want to create a scan world and freeze the registration. And then we want to open the model space view. Now from here, we have a point cloud that we can now finally work with. The only step beyond this is to now unify your point cloud together. So I have one here that's already registered and unified, and that's registration number 1. So the unification process only takes about 30 to 45 seconds, but I'd rather save that time and go right into the data as opposed to going over that and have all of you watch a bar run through the screen. So again, we're here at our auditorium. From here, within our own software, we have plenty of 2D and 3D brake line creation tools, wireframe tin creation tools, modeling tools. But again, we'll reserve all of that for the Imagine an event coming up later in December. Today's purposes are just to show you how easy it is to collect the data. Again, you saw me walk up to the scanner, push a few buttons, and then everybody saw the scanner rotate. From there, it's simply a matter of downloading the data onto your laptop and then walking through the registration process, which is what I did just now. And for those of you interested in maybe a target-based registration, you can see that we have onboard controls on the scanner there. On the onboard controls, there is a crosshair hatch right in the center of the screen. All you do is label your targets out in the field, tell the scan head what type of target it is, because we have algorithms built in which search for the reflectivity of those targets. You manually grab the scanner, turn it to your targets, zoom in till you get the crosshairs over the target face, acquire that target, and again, it'll use the algorithms based off the reflectivity of those different target faces, and then it'll snap a vertex on the bullseye of that target. You then use those vertexes or vertices as your constraints to register your stations together. So with the dual axis compensator that we have inside the scanner, we can traverse through a job site, so you only have a back site, a foresight, and close your traverse, and when you do that, all of your stations are automatically registered together for you. So upon import and when you open the data set, you have a data set that looks just like the one that we're looking at here. But instead of having 2 stations inside there, we would have however many you needed with our targets located as well. So once you register your point cloud, bring them all together, you now need to at least perform some minor cleanup to it before you can get it into a workable file format that you would therefore take into any of your Autodesk products, being Revit, of course. So if you're out in a roadway, for example, and you have cars driving by, or like today we had people walking in and out, we're going to treat these people right here as noise. As you can see, I'm zooming in around them. So all you have to do is get a nice plan view and pick a fence of an area that you want to work within. The laptop always seems to work a little bit slower when it's connected to a projector. So with this fenced area now, I'm going to tell Cyclone that I only want to work with inside this fenced-in area. From here, I'm going to pick a few points on the ground that I know are ground shots and create a smooth surface. I have a hotkey for smooth surface instead of running through all the tools for you. And we can see that all of the points highlighted in white reference the smooth surface that we want to create. And everything that's not highlighted in white, we're going to consider noise. So I like my results and I'm going to hit OK. Everything not on this white is now highlighted. From here, I can simply hit delete or go into my layer manager, open up a new layer, call it noise, or again, whatever you would like, assign those objects to the noise layer, and then turn their visibility off, and just like that, they've now disappeared. So we could do the same thing with the podium or any other objects. And again, like I said, there are plenty of tools inside of Cyclone to help you navigate through this cloud of points or point cloud, model objects that you're interested in modeling in, or creating 3D line work. And you can also, excuse me, you can also code the points that you use for your polylines, create an ASCII file or a text file list of those COGO points, and export those out as a text file or an ASCII file or whatever you would like, and you can bring that directly into Revit as well to start your mapping from there. So are there any questions before I hand it over to Ken?
What was the program called?
This is Cyclone software. We're looking at Cyclone Register and Cyclone Model today. But again, I'm going to save all of the modeling features and that for the event at the Imagine office. Okay. Absolutely. So I can zoom all the way out and go from a perspective view to an orthographic view and get a nice side view like this. And you have plenty of different options of ways to just view certain areas. An easy one is just what we call a lawnmower trick. Grab any area and copy that into a new model space. So if we look down here now at Cyclone, we now have 2 separate model spaces open. So within our software, we recommend all the time that users grab smaller objects, pick on those smaller objects, manipulate them, code points on them, model them, perform whatever deliverable you want, and then jump them back into the original point cloud. Or, as you can see here, when I'm about to export or leave or close this out, it's going to ask me if I want to save this now as its own separate project, which is a good idea if you then want to grab this roof by itself and open that up inside Scan to BIM for Revit, which again, Ken will be showing that. But I don't want to give away the farm here. There are plenty of options in here. I could start modeling these lights. I could model some of the information up here. It's a shame none of the drop ceilings are missing, because then we could show some actual utilities up there, and I could go to town on those all day long. But again, I just want to show a brief overview of how you collect data, how you register data, clean it up, and then get it into a format that Scan to BIM and Revit can also use. Go ahead. So we have 3 settings for our internal camera: low, medium, and high. I had it on low today, which is about just over a 5-minute photo acquisition. And even at a low resolution, the scanner takes 260 photos and tiles them together. And at low resolution, you have 1 megapixel per tile, so you still end up with a 260 megapixel file photo for your full dome. We also have medium and high resolution. Medium has 2 megapixels per tile, and high has 4 megapixels per tile. But the reality is, for a space this small, you're going to want to keep it on low at all times, because the higher resolutions only come into play if you have objects right at a great distance that you zoom into, that you start to see some pixelation and things like that. Any other questions?
It takes an awful lot of points. Why just to register, so to speak, by hand? Just pick when you're doing the vertical, just keep it really simple. The concrete floor is pretty more or less flat, no carpet and stuff on it. So there's an awful lot of points, but you just visually get the 2 flows together. Is when you went to that next step, is the machine saying, oh, well, okay, visually, you got them pretty close, I'm going to finish that job, or did it leave them wherever you put them visually?
That's a very good question. The software has algorithms that run that will do a least mean squares adjustment. So we'll actually adjust the two clouds together for you.
Okay, so you're just visually giving them the neighborhood, then the machine does a little statistics.
Exactly. And I believe with the new visual registration tool that we have, you only have to get walls to within 8 inches of each other to be able to run those algorithms. The algorithms are going to only search for 8 inches from station 1 to station 2. You get an 8-inch search radius to then run that least mean square adjustment.
Thank you.
Any other questions? I'm sorry?
Within Cyclone, how do you line up with the Revit model you want to work with that scan file there? You bring in the PWG file there that we give you as a grid system? Or?
Yeah, very good question, and I'm sorry for not covering the export options. So Ken will get into more of this in a little bit, but I would at least like to show some of the export options that we have. So I can select the entire ceiling, for example, and then go into my file export, and hopefully the screen up there is large enough. Yes, we have all of these different export options to utilize. And if you were to model that roof, the ceiling, which again, inside Cyclone would be a very easy task to do, we have a free export option called COE that you can go to Leica's website and download for free. It stands for Cyclone Object Exchange. And any object that you model inside Cyclone, you can go right here to .coe format and save that as a COE into whatever folder you want, your desktop or wherever. And then when you open up Revit, you can type in a command, COE in, and COE in that object directly into Revit and work with it. But yes, you've got land XML files when you create wireframe tins. You've got .pts, PTX, PTZ. I mean, there's all these different options up here.
Can you talk a little bit about the workflow of not just registering the point clouds from one setup to another, but maybe to some kind of origin or control point so that when you bring it into Revit, the point cloud is in the same spot as your model information if you're adding to or having some kind of a survey point that you can take. Because one of the things that I've really liked about the PTS files that I've got, we don't own a laser scanner, but we use service bureaus that are essentially able to give me a PTS file. If I bring it into Navisworks, has the same exact origin as our survey. So a little bit about how to set that up and how to export it.
Yeah, absolutely. So I mentioned earlier that our scanners have a dual axis compensator, and this is a real-time dual axis compensator that will compensate to the scanner in any direction to within 6 degrees while you're out there in the field. And we also have a laser plummet on the scanner as well, which means you can set that scanner up over any known control point provided by a land surveyor. We also have our target poles that you can set up over control as well. And with the dual axis compensator, you can resect to your position and create a known position for the scanner itself. So the beauty of that is that you can set the scanner up anywhere you want on the job site, out of harm's way. If there's machinery or a lot of people moving around or people that are performing work, set the scanner up wherever you want, put your targets up over control, reset to your position that you've now created, and then scan away. And then as you see here, when I pick up on any point within the point cloud, the XYZ or northern easting elevation values appear in the lower left portion of the screen. So had I brought in control today, total station, out to targets out in the street, traversed into the library, set my targets up or the scanner up over one of those control points, I could have easily referenced this to our state plane coordinate system today. And then that is how you would tie in all of the existing coordinate system, whether it's a control system or proposed design, and tie that in with the Cyclone database. Because in the registration screen, it doesn't care. Let me open this up really quickly. Here in the registration as a constraints list, it doesn't care if your control file has 12 setups or 12 constraints or 100. It's going to treat it as a station with the scanner. So all you have to do, the important thing to note, is that when you're labeling your targets and you have them set up over control out in the field, or you're labeling the station and you set the scanner up over a control point, that you label them the exact same label that you have them on your control file. And then it'll tie those in as the constraints into the registration process.
Do you have an option to import into this environment? Say that you didn't do that in the field, but you've got a survey.
Mm-hmm.
Do you have the ability to import, say, a CAD drawing and tell it, you know, just like you move the point cloud, move it to within, you know, visual range of where you want it to be?
If you're tied to control and you have the same control points, yes, it'll bring it in the same space, the same general space. So I just highlighted the project database folder here for today's project and just went to an import as opposed to import scan data. And then from here, you can import all of these different file types. So you can bring in a text file of a control file or an exported object out of Autodesk products and bring them directly into Cyclone as well too. And there's a lot more options here on import than we have on export as well. Any other questions? Go ahead.
Is there dimensioning available on your program?
I'm sorry?
Is dimensioning available and how accurate is it?
Yes, absolutely. It's as accurate as the point clouds. The raw point cloud information with our scanners is accurate to within plus or minus 3 millimeters. And we maintain that by the scan head themselves, only collecting data points that are smaller than 6 millimeters in point spacing. So, for example, if we want to check the resolution that we have on this wall here, I can simply zoom into the wall, collect 2 points, and then measure the distance between those 2 points. So I'm just barely over 1/10 of an inch resolution on this here, on the wall. But I can also then pick on this wall and then fly over to another wall and pick over here to get a distance. So again, these are more Cyclone features that I would love to show off and go through, but again, that's a whole different presentation. But again, the raw point cloud information is accurate to within plus or minus 3 millimeters. And it's important to note that with the least mean square adjustment that you also run when you model an object, if I were to model these 2 walls here, then we typically achieve 2 millimeters of accuracy on those modeled objects. So I want to thank you for your time. Again, I don't want to give away the farm, as it were, and we can save Cyclone for another presentation another day, because today we really want to focus on Revit and how you guys can bring in these point clouds into Revit and actually work with them. So Ken Yost is going to talk about our Scan to BIM product, which is essentially a plug-in into Revit, which allows you to navigate through these clouds of points and create your deliverables inside of Revit. Thank you very much.
Well, hello everybody, good afternoon. My name is Ken Yost from Imaginative Technologies, and I've been on this side of the table now for way too long. 26 years-ish.
When I met you, I had brown hair.
So obviously, you guys kind of know what's going on with scanning. We could go out in the field and we could, you know, with our notebooks and our digital cameras and our tape measures, we could try and do as-builds so we could get a scanner. The way it works is basically, you saw it, we're going to take this and we're going to turn that into Revit objects. And the way we're going to do that is, let me find my Revit again. Where did my Revit go? There it is. I'm going to go ahead and start up just a new project. And there's a lot of ways you can do this, but if we're going to just do it, let's say we just have Revit and someone cleaned up a scan for us, and now we've got the point cloud information. So we're just going to go ahead and say insert a point cloud. And I have one. This one is it's about 4 years old, I guess. Is it not? Oh, hang on. I did. Why is that not switching to my Revit? One second. Okay, hold please. We'll just do this. Oh, that's much better. So let's back up. Let's try that one more time. So insert a point cloud. And you can see we have a RCP file. This is the file that's produced after you stitch together all the different scans. And we'll bring it in. And you can see it looks like that. And we can spin it around. And you can see our project. Now, obviously, if I wanted to, you could go into here, and I'm going to go to my site plan. And just with my tools, I could come in here and I could start to pick, because we can pick on point clouds information. Just pick on the information and start to create lines and do our walls and things like that. The problem with that is you might not always know exactly what you're picking. And you can see that over here I didn't quite do what I thought I was doing. Okay? So what I like to do, and what I'm going to show you today, is the way that we can literally go in and use Scan to BIM to help us generate some of these objects. So I like to start over here, and I'm just going to go ahead and say I want to create a wall. And I'm just going to pick a couple of points on that face, and it says it found it. It says how much tolerance do you want, and what type of wall is it. And of course the nice thing about this is here are my Revit walls that I have already made for me. I'm just going to say I want a generic wall, and I have two choices. I can say create a profile wall or create a mass wall. A profile wall is when your wall is pretty much straight, we'll say straight, vertical. Massing wall is when your wall is at an angle. So a massing wall will literally go in and make a mass at the angle, then create a wall at that angle, and delete the mass afterwards. So if you have some sort of wall at an angle, a mass wall. If you have straight walls, profile walls. So let's just go ahead and create it. And if I toggle off my point cloud, you can see there's my wall. Real simple. Doesn't take very long. We can just do a couple here. We'll say, yes, that looks good. And of course, it says that the walls are slightly off axis. And I may need to do some cleanup. You can see I've got a little bit of cleanup there I'm probably going to have to do on the model. If we go back and we look at this now, if I pick on that wall, it's going to tell me that it's at, one of my favorite angles, 44.496 degrees. Because that's what it recognized this wall at. And then I can go back if I want to, and I can tell it, well, I know you're really at 45, or I can leave it at what it was at. I also have some other tools. I can go in here and I can create arced walls and just grab a section that I want here. And again, I'm going to use my generic and create it. I can also, when I create the arced walls, I can also come in here, for example, and say, I'd like you to be a storefront. And then if we toggle that off, you can see what we're starting to create. So the nice thing about Scan to BIM is going to help me do some of my work. It doesn't do everything for me, because there's parts of the building where we've got things that we're going to have to figure out what's going on. You know, if I toggle my cloud back on here, and we go look at, you can see up here in front, we've got some situations where we have some recessed windows or openings. We're not quite sure what they are, that we need to go work on. And to do that, and I almost like this tool outside of, not just for Scan to BIM, but I can go ahead and I can create some sections. And I can say, oh, I'd like to have 20 sections in the X. We'll have 35 sections in the Y. Each section will take up 3 feet, and we'll rotate them at 45 degrees, and we'll click on OK. So now I can go in, and anywhere I want to, I can go look at the section through my building to kind of see what's going on. So I'm going to go ahead and undo that. I can also, as Joshua pointed out, when the point clouds are big, if your machine isn't super beefy and you want to work on a small area, I can just come in here and grab an area that I want to work on, and it'll create a nice little section for me so I can see what I've got. Let me zoom in there. That wasn't the best view, so hang on. There we go. That's better. I want to pull that down so you can look at it. So I can zoom in on a smaller area to work on it and make it a little bit faster for me and not worry about the stuff outside of it for a while. Now, there are a lot of tools that we can do in there to help us. One of the other tools that I wanted to show you here is we'll go back to Scan to BIM, and we'll use the deviation tool. And I'll say, that's fine, and I'll go with a few more points. Well, actually, let's say we want to see anything within 4 inches. So plus or minus 4 inches, we'll say, and we'll go ahead and pick this face, and we'll update it. And now it's going to show me on this wall how my wall that I created in Revit compares with the actual cloud. And you can see here that now I'm at 2 inches plus or minus. So anything in orange is 2 inches away plus or minus from the cloud. And we can get down so we're within 0.2 of an inch in some spots on our wall. So you can kind of try and see what's going on. If for some reason your wall is way off in one area, you can try and figure out how come it's off. You know, we don't know what the wall is made of. The wall could be, 100-year-old masonry wall, and it probably was never perfectly vertical to begin with anyway, so. Now, another thing we can do with it that I like to show people, actually a couple more things. Okay, we're doing okay. Is I'm going to go ahead and I'm going to open up a project that hang on, let me just close this out real quick. I'll open up my pipe room for us. And I'm going to go ahead and insert a point cloud again. This time I have a little, it's an RCS file, a little pipe room for us. If we create a 3-dimensional image of it, You can kind of see what we've got. Now, the thing that I like to do is, in this room particularly with pipes, sometimes it's hard for me to see it like this, so I can go in and, from Joshua's talks, you should see that we could go, I like to do normals in the pipe room, so it actually will show me the pipe a little bit better. And then what I'm going to do is I'm just going to go ahead and create some pipe. I'll grab onto that pipe piece right there. And now it's telling me that it recognizes this as 11.8 inches. Okay, and the closest one I've got is probably 12 inches. So that's what it's saying. It's saying, I see 11.8 inches, I've got a 12-inch pipe. So I'm going to go ahead and create the pipe. And let me change it to fine level of detail, and you can see that there is our pipe. Make another one for us. Over here, grab that. Ooh, let's not do that. Well, yeah, let's try that one more time. I didn't like the way I grabbed it, so let's try and grab it like that. Is that any better? That's a little bit better. So we'll go ahead and create pipe. And obviously you can see here, this is probably good, you can see that these pipes, there's no way that they line up with each other, right? When I scanned it. So I have a little adjust pipe tool that I can pick on these two pipe, and it will give me options for how I want to line them up. Well, I'm going to go ahead and rotate it, which means that this end of the pipe is going to stay where it's at, and I'm going to rotate it into hopefully a better position. Cross your fingers. I've never tried to do it on something that was that out of. Come on, there we go. So there it brought the pipe together for us, and oh wow. I can see I really got the wrong stuff when I was going for it. Now, another tool that you can use is, Revit doesn't really have any equipment in here. So you can still use our Revit tools. You know, I'm going to make an arced wall, and I'm going to grab that, and I'm going to say I'd like that to be just a generic 5-inch wall because I just want something there as a placeholder to take up that space so I know not to run into it. Now, another nice tool that I like is we also can go ahead and create columns right off of here. And the thing that I like about this is it will tell me the size that it finds, and if I don't have the size, I can actually create the size that I want. I'll just say 8 by 10 here. I can actually create the size that I want without having to go back out of my tool and create it. And you can see there we have if we turn the point cloud off, you can see kind of what we're doing. Now the last one I'll show you, how are we doing on time? We doing okay? The last one I'll show you real quick here is we'll go ahead and start up a new file. And I'll go ahead and, how do I want to do it for us? 1 second, let me take a quick peek here. Yeah. So let me bring in a DXF file. Right there it is. And this really doesn't have anything to do with a point cloud. I just like to show this to people because it's kind of cool. Here we have some, well, we'll say pipe. It's just from some other product. We don't know where it came from, but we have a DXF file. And so now we'll go ahead and just say we want, and let's see, that looks pretty good. We'll say a minimum diameter of, let's say 1, maximum, okay, and we'll say next. And then right here, it's telling me what it found. So it found 29 objects that meet the criteria that I gave it. And when I click on OK, I'm going to just say create pipe. And you can see right there what it did. So even if you don't have a point cloud, if someone sent you a generic drawing that you could have as a DXF, you could create the pipe and start to clean it up from there. Any questions about it? Yes?
How you create it, does it have any intelligence? BIM-wise?
The pipe that I did with single pipe, that's actually Revit pipe. And the pipe that we have in there now is Revit pipe. So these are all Revit objects. And the question was, does the pipe have any intelligence when it comes in?
Going back to the scan, scan from scan to Revit,
Mm-hmm.
and you created walls from, you can create a wall from a mass if it's sloping. Can you go along and do creating masses from a scan?
You can. Scan to BIM wants to create Revit objects, but there's other tools that will actually create masses from it. And from the point cloud, and I think, Joshua, if I'm right, Cyclone will create masses from the point cloud.
Unfortunately, I'm not very familiar with Revit, so I do apologize to everyone today.
Right. But the question was, can you create masses? And the answer is yes. Scan to BIM doesn't do it. Scan to BIM is all about creating Revit objects.
Because once you build the mass, you can apply.
Right. And that's what, I guess what I would say if we were going to use Scan to BIM, the create mass wall is how you would do that. Because that creates a mass. Then once it's found the mass, then it puts the wall on the mass, and then it deletes the mass after it's done. So that's as close as we would get in with Scan to BIM. Any other questions?
The tool you just used for the pipes in the sea, that tool does not work on the point cloud, is that correct?
Can you repeat that a little louder?
The tool you used where you took the DXF and you said find anything that looks like a pipe and create the object, that does not work with the point cloud, is that correct?
That's not for the point cloud. Now I didn't show it to you, and we'll talk about that at the workshop, but I also have simply because I don't have a nice model I want to show you, I have an auto-find pipe, which does work on the point cloud. And we'll try and see all the objects that it thinks are pipe, and it will try and turn them into pipe. But I don't have a real nice model for that. So I'm going to try and find a nicer model that will.
Do you have the same tool for walls? Find all walls?
No, we don't. So the one that I showed you was just, let's say you got a CAD file from somebody that wasn't using AutoCAD. It was just somebody else's product.
So for a historic building, where you have the proverbial masonry wall that bows out a little in the middle and it's a little wobbly, but you don't want to pretend that it's square. You don't want
Right.
to pretend that it's flat. You want it to be exactly what the hell it is. It's just like the wobbly, bow in the middle, not quite square wall, because you're going to marry a new building to the old building.
Right.
Or you're recording it because you're going to want to pull that bow back in with some ties. So you want to record that and have a Revit object that represents that. How do I do that?
Create the mass. That's the mass wall.
Okay, and so I just leave it as a mass wall, and it'll be whatever irregular shape it is.
Right. And then Revit will do its best. Now, I haven't thought about it. That would be an interesting thing. I could create a slab, and I have an auto-adjust slab tool, which I can literally go in and kind of scooch the the wall up close to the object and then start picking points on the cloud, and it will start deforming the slab to those points. And that would give you your more wobbly shape. I've only tried it on, you know, like a sidewalk, but it would be an interesting thing to try it on a wall. Right. Yeah. This wall is not straight. Anything else? Okay, let me go ahead and turn it back over to Robin real quick. Let me bring this back up for her. I know, Camtasia. We're all we know. And hang on, let me get to the slide here real quick for us. And then I'll get the, okay. So, that should be, all right, Robin? And then your slide. Don't be shy, guys.
Well, we'd like to thank Joshua and Ken for doing their demonstrations. And as they said, we are going to have a lunch and learn so that you guys can learn firsthand how to register the data, do 3D data collection, clean up the cloud points, and do data extraction. So we would like you guys, if you haven't, to sign up there, or you can contact either Robin or myself to sign up for that lunch and learn. Or if your firm wants to have a lunch and learn, then just contact us and we'll schedule that as well. So we'd like to thank you guys for allowing us to come in and have these guys present. So
Thank
you
you.
very much.
Well, thank you very much. Before I get to the giveaway, I'm going to be a little controversial and say something that maybe flies a little bit in the face of what we've heard. Just because from personal experience, I've dealt with the question that was asked about the historic buildings, and I would encourage everybody to think outside the box when it comes to the value of laser scanning, and realize that if you have a point cloud, you have the wobbly wall. And if you bring that into Revit and you cut a plan through it, it looks just like a floor plan, it looks just like a section. Do you really need Revit objects of a point cloud in certain situations? If you're going to add a new building to an existing building, you can simply delete some of those points, have new walls where there's new walls. So while there's certainly cases where creating geometry is appropriate, I would encourage everybody not to think that you always have to do that. It's been kind of my experience that people expect certain things because they're standards to be followed and what we usually do and what our output usually is. But there's a great deal of value to what comes out of this machine as it is, especially as hardware's gotten better and faster, and computing power is getting very cheap. So sometimes carrying around a couple billion points is not the tax that it used to be. But anyway, I'm on a roll today getting up here on the soapbox, man. Anyway, I've got a couple of Amazon gift cards to give out, and maybe our presenters today can do me the honor